Good day, this is the Professor, CBMD PhD, and today's Friday, October 20th, 2023. It's 2:30 and 9 seconds, AM Eastern Standard Time, and today's research, black holes. So let's jump to it here. As black holes can come in perfect pairs in an ever-expanding universe, date October 19th, 2023. Source, University of Southampton. And black holes are massive, astronomical objects that have such a strong gravitational pull that nothing, not even light, can escape. They are incredibly dense. A black hole can pack the mass of the Earth into a space of the size of a pea. Conventional theories about black holes, based on Einstein's theory of general relativity, typically explain how static or spinning black holes can exist on their own, isolated in space. Black holes in pairs would eventually be thwarted by gravity attracting and colliding them together. However, this is true if one assumes the universe is standing still. But what about one which is constantly moving? Could pairs of black holes exist in harmony in an ever-expanding universe, perhaps masquerading as one? The standard model of cosmology assumes that the Big Bang brought the universe into existence and that approximately 9.8 billion years ago, it became dominated by a mysterious force, coined dark energy, which accelerates the universe at a constant rate. The scientists refer to this mysterious force as a cosmological constant, and the universe explained by Einstein's theory. With a cosmological constant, black holes are immersed in a cosmological accelerated background. This moves the theoretical goal, host over black holes can interact and exist together. And through complex numerical methods, the team behind this latest study show that the two static non-spinning black holes can exist in equilibrium, their gravitational attraction offset by the expansion associated with a cosmological constant. Even in the acceleration of an ever-expanding universe, the black holes remain locked at a fixed distance from one another. As hard as expansion may try to pull them apart, the gravitational attraction compensates. Viewed from a distance, a pair of black holes whose attraction is offset by cosmic expansion would look like a single black hole. It might be hard to detect whether it is a single black hole or a pair of them. The theory is proven for a pair of static black holes, but they believe it could be applied to spinning ones too. Also, it seems plausible that their solution could hold true for 3 or even 4 black holes, opening up a whole range of possibilities. And this is the Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.